And welcome back. We only have a few short weeks until the Christmas break, so let's bear down and get this done. The topic that we're going to talk about today is angular and linear velocity. This is not an easy topic because this is, again, where physics comes into play, and I know you all love physics and how real-life problems come into math. So let's go ahead and take a look at these, and here we go. So today's objectives, you're going to go ahead and represent angles in radians and degrees, and based on the concept of rotation in the mathematical real-world problems, including linear and angular velocity. So first thing we got to, in order to talk about linear and angular velocity, it's which you have to understand about what we're going to be talking about. We're going to talk about the velocity or the speed of how fast something rotates around a circle. And there are two types of speed, okay? And we'll talk about them. But before we can cover about the speed, we need to first talk about our distance around a circle, or arc length. Okay? Our arc length is just a simple formula, or the distance that was traveled is S is equal to theta times R, where theta is equal to radians. We use radians, okay? And it's going to always be radians. It makes life a whole lot easier. Times my radius. Radian times radius. This here, S, if you haven't, this is distance traveled. When I do distance traveled, I don't care about how fast I'm going. The only thing is that I care about is what angle, how many angles or radians did I travel, and what was the radius that I traveled on. And so let's use that formula to go ahead and solve these next few problems. So in the we do section, okay, my radian is pi over 4, R is, I don't know, is 3, and S I need to find out. So again, I just set up my formula. I just plug in what I know. So again, my formula being S is equal to theta times R. So S is equal to pi over 4 times 3. Well, it's equal to 3 pi over 4. That's pretty straightforward, right? What happens if I'm, again, bring up a third grade type problem, okay? This one here, they don't give me the radius. So again, I just plug in what I know. 14 is equal to 7/8 of a radian. Okay, so 7/8 times my radius, which I don't know. So how do I undo 7/8? Well, I multiply each side by 8 over 7. Multiply each side by 8 over 7. All right. And when I do this, I can go ahead and pretend, hey, that's a 14 over 1. I know that 7 goes into 14 2 times. So 8 times 2 is 16, which is equal to, well, the 8 and the 7s cancel out, is equal to my radius. And what do you think my 16 what? It's going to be 16 meters. Forgot to discuss this up here. It's going to be, my distance traveled is 3 pi over 4 inches. Units are going to be very important with this. Very, very, very important. So we need to make sure that we include them in our examples. So now I'm going to have here, these are two for you to do. I'm going to go ahead and pause the video. If you're watching on YouTube, pause me now. And when you get done, you'll see the answers and see if they match up. See you on the flip side. And bam, there are the answers. Okay. S is equal to 8/3 feet, and theta is equal to 3 radians. Okay. If you have questions on how these look or where I got the answers from, make sure you bring that up tomorrow. So now we're going to get into the meat of the discussion. I didn't give you this one because I didn't want you to be confused by it. It's a key concept. We're going to talk about linear and angular speed. And I'm going to get more into each one individually. I didn't want to bring them both up at the same time. So here we go. Angular speed. So angular speed is how fast an object goes around a circle. Angular speed represented, okay, so let's talk about what angular speed is. So here I am. Here's my little dot. I'm going to get a little dot. Put it right here. My angular speed is how fast is my angle, this angle here, how many radians am I going through per second? Okay, I don't care about the distance. Okay, I don't care about that. I don't care about the radius. When I try to figure these out, the only two pieces that I care about is my theta, which again is in radians, and how much time. Omega, that's how you pronounce it, omega is equal to, that's my angular speed. It's exactly what it is. It's saying how much angle are you going through per time. Radians per time. Okay? That's all it's asking for. Radians per time. So let's take a look at an example of what this would look like. This first example says a bike wheel with a radius of 10 inches is rotated by 2 pi thirds radian in 4 seconds. How fast is the wheel rotating? So some key things to know that I'm looking for angular speed. When they say how fast, you might be thinking, ooh, that might be, well, we have two types. The linear, which we haven't gotten to yet, and the angular. So how do I know to choose angular? When it talks about something rotating, it's not talking about distance traveled. It's not talking about how fast is the actual bike. It's just saying how fast is the wheel rotating. So when I know that I have my omega is equal to theta over t. Well, they give me time. I can easily find out. Look. Here it is. 4 seconds. So there's my time. That's going to be t. But they do not give me, do they give me my theta? They do give me my theta. Look. Because remember, theta is in radians. So did they give me it right off the bat? You betcha they did. There it is. So now I just go ahead and plug in what I know. So omega is equal to 2 pi over 3 divided by 4. You're going, ew, fractions. Okay. Again, you can use your calculator. 2 divided by 3 divided by 4. Math, enter, enter. Or you can just do it the mathematical way, which tells me that this is going to be 2. This is the same thing as 2 pi over 3. Instead of dividing by 4, I can multiply by its reciprocal, which is then equal to 2 pi over 12, which is equal to just a pi over 6. And what's my units? My units are what it is over what it is. Radians over time. Radians over time. So radians per, what's my unit of time? Seconds. So how fast is my wheel rotating? Pi over 6 radians per second, which is not very fast. So let's put that into reality. What does that look like? So again, here's that circle thing that we came up with. Here's this, pi over 6. Okay, I use my conversion, right? Pi over 6. Radians is how much in degrees? Is times, okay, 180 over pi. The pi's cancel out. 180 divided by 6 is 30 degrees. So on my circle, what does 30 degrees look like? My terminal side comes up here. There's my 30 degrees. It traveled this far in 1 second. So that bike is moving very slow. All right, so let's take a look at what's next. Next example. Says, here we go. This example says a car wheel of diameter 24 inches made 3 revolutions in 4 seconds. How fast is the wheel rotating? Okay, so again, I take a look at the question. It says how fast. Okay, good. I got two velocities, linear and angular. Which one am I going to use? Wheel rotating. Oh, wheel rotating means I'm going to be using angular. I need to find my angular velocity. So I'm finding my angular velocity. I write down what it is. It's equal to theta over t. Again, oops, same 4 seconds. I found my t. 4 seconds time. That's t. And then, okay, 24 inches. Is that a theta, which is radians? Nope. Made 3 revolutions. 3 revolutions. Uh-oh. They don't tell me radians. They do tell me 3 revolutions. So do I put 3 in there? No. So how do I figure this out? Well, we have to go back. I want radians. And it went around 3 times. Around a circle, twice, 3 times. How many radians are there in 1 time? Oh, remember? 1 time around, there's 2 pi radians per revolution. Okay. So I can get my radians right away by just multiplying 2 pi times 3. So my theta is going to be equal to 2 pi times 3. My 3 revolutions. And what do I get? I get that is equal to, my theta is equal to 6 pi. And now I go ahead and put it in there and I say, okay, well, my angular velocity now is going to be 6 pi divided by time, which is 4 seconds. 6 divided by 4 is equal to 3 pi over 2 radians. Okay, so now I got to go again. What is my units here? My units are radians per second. And there I am. So that's angular speed. Let's talk about linear speed. Okay, so in linear speed, guys, it's how fast is the object that is spinning would go if the object was traveling in a straight line. That is, okay, so now I have my wheel, right? My wheel is going along here. I have my wheel. And it's asking me if I were to have my dot start here, right? And I start rotating around and I use my theta and I find this stuff out. I rotate. They'll be asking, how far is that? They want to know what this distance is. Okay, how fast did I travel this distance per unit of time? That's what the linear velocity is, traveling this distance. Well, how did I find that distance before? So back in that first section. That's s per unit of time. So s is measured in distance and unit of time. So here's some things. So not only do you need to know that velocity is equal to distance over time, but you also need to know in order to find my distance, I need to know that whole theta times radius business. So I could even stretch this out and say that velocity is equal to not only the distance, I could also say is theta times my radius over time. Both of these are true. So let's take a look at some examples. So example 1 says a bike wheel with a radius of 10 inches is rotated. Hey, this is the same thing that we just got done doing, except look at the question. It says, how fast is the bike traveling down the road? The bike traveling. It's not asking how fast the wheel is rotating, it's asking how fast the bike is traveling. So when I think that, I'm thinking linear speed. So I'm thinking, oh, okay, so I'm going to need to know that velocity is equal to s times t. And then I need to remember, oh, what is s? So I can write this over here. S is equal to theta times r. So it says a bike wheel is a radius of 10 inches is rotated 2 pi 3 radians, 2 pi over 3 radians. in 4 seconds. They actually give me everything right there, don't they? Because why? I need to know theta. Did they give me a theta? Yes. I need to know my radius. Did they give you a radius? Yes. And then I need to go ahead and find out time. I need to know a time. And did they give me that? You betcha. 4 seconds. So let's go ahead and just plug in what I know. So first thing I do is got to find my distance. S is equal to radians, 2 pi over 3, times my radius, which is 10 inches. I just multiply the top, and this is equal to 20 pi over 3. Notice I'm not putting this in a calculator yet. I do not want to put it, find out the decimal until the very end. Okay? But what's my unit? 20 pi over 3 what? Inches. That's what my radius is. Great. So then I come over to the velocity part. Now I know the time. So then again I have here velocity is equal to 20 pi over 3 divided by time of 4. And then I say, well, what's velocity? Velocity is measured in, not velocity. How do I do this? Well, it's the same thing as saying 20 pi over 3 times 1/4, which is equal to, well, I can simplify by saying there's 1/4 goes into that 5 times. So this is 5 pi over 3. That's my answer. But what are my units? Units. So velocity is measured in distance per time. What's my distance measured in? Inches. Per. What's my time? Second. There is my final answer. Okay. One last example and we're going to be good to go. This last example is going to say a bike wheel in the diameter of 24 inches made 3 revolutions in 4 seconds. How fast is that car moving? So again, S is equal to S. I need to be able to figure out how fast. Okay, so that's my velocity. Car moving, linear velocity, because it's talking about the car moving, not how fast it's rotating. So that's velocity is equal to distance over time, but I also have to know that distance is equal to theta over r. And I'm going to use some of our previous stuff. Did they give me theta? No. But there's 3 revolutions times 2 pi. So theta is going to be equal to 3 times 2 pi again. And my r is 24. So my distance is equal to 6 pi times 24. Which is going to be equal to 144 pi. What's my unit? Again, it's in inches. And that's that. And now how fast? In seconds? 4 seconds. So I have 144. So now my velocity is equal to 144 pi. Time was 4 seconds. Divide that out, is equal to 36 pi. Now again, what are my units? Units are distance per time. Distance per time, so distance is going to be, again, in inches per time is seconds. And there's my units. Done. All right, so those are the 4 examples. I do have one more big giant example, so let's take a look at it. Boom. So here it says, I have a typical vinyl record, has a diameter of 30 centimeters. When played on a turntable, the record spins at 33 1/3 revolutions per minute. Find the angular speed in radians per minute of a record as it plays. Okay. So, let's take this down. I got this here. They're asking straight up for angular speed. That's easy enough for me to do. I'm going to write that down. Omega is equal to theta over time. Do they give me a time? Yes. they say here per minute. Okay. How many? Okay. So it goes down pi, 1 minute. Okay. But what is my theta that I travel? Wait. Again, I have this problem of revolutions. So whenever I see a revolution, if I see the word revolutions, I need to be thinking, oh, I need to change that into radians. How do I change that into radians? Multiply by 2 pi. So my theta is going to equal to 2 pi times 33 1/3 revolutions. So my theta is equal to 66 2/3 pi. What's my omega then? Well, 66 2/3 pi was my revolutions. How fast did I do that in? Or my radians? I did that in 1 minute. So this comes out to be really kind of simple. 2/3 pi. Okay. Radians. That's my unit per minute. Bing, done. It says round to the nearest tenth. Here's an exact answer. I'm not going to go and grab a calculator. You can go grab a calculator and find out what it is. Okay. So let's go next. All right. So in this one, part B, they say, okay, so it's the same information, except take a look at this last piece. They say here, find the linear speed. Oh, let me go ahead and write that down right away, that my linear speed is equal to some s divided by time, some distance divided by time. But I also need to know that s is equal to theta divided times my radius. Okay. Well, so let's keep reading here. So I want it in centimeters per second. This is very important that I get this to match. So let's talk about s. I always want to find s first. In our previous example that we had, we found out that my theta was 66 2/3. So I'm just going to reuse that. Pi. But what's my radius? You come down here. Oh, look, hey, it says it's 30. No, it's not. My diameter's 30. So what's my radius? 15. And this is the beautiful part about why I don't like using, trying to find out, decimals right away. Because 66 2/3 pi times 15 is a nice, happy 1,000 pi. Great. What is that going to be measured in? Centimeters. So my distance traveled is 1,000 pi centimeters. All right, so now I find out my velocity. My velocity then is 1,000 pi centimeters. Oh, that's my s over time. How much time did that happen in? I read up here again that happened in 1 minute. So in 1 minute. So again, my units here are centimeters per minute. And you think I'd be done. But wait a second, I'm not done. Let me rewrite this here. I'm going to say that it's centimeters per minute. So, am I not done? They want centimeters per second. So, I need to change minutes into seconds. So, I need to use that whole dimensional analysis that we do in chemistry and physics and say, okay, so I want to get rid of minutes. I want to change it to seconds. Well, how do I do that? Well, I know there's in 1 minute, there is 60 seconds. And how did I know to put the minute on top? Well, here's how. I wanted to cancel out my units. Cancel out that minute with that minute, and I'm left with centimeters per second now. Okay? When I do this, now this is equal to 1,000 pi over 60 seconds. Okay? So, which would then equal to 50 pi over 3. Now I'm in centimeters per second. There's my answer. All right. Again, sorry about the length. Come tomorrow ready to go. Talk to you later. Bye.